Hello, I'm Puck and I'll be narrating this video, The Alien Rock That Built Rome's Empire. Trachyte is an extrusive igneous rock composed mostly of alkali feldspar. It is usually light-colored and aphanitic, fine-grained, with minor amounts of mafic minerals, and is formed by the rapid cooling of lava or shallow intrusions, enriched with silica and alkali metals. It is the volcanic equivalent of syenite. Trachyte is common wherever alkali magma is erupted, including in late stages of ocean island volcanism and in continental rift valleys above mantle plumes and in areas of back-arc extension. Trachyte has also been found in Gale crater on Mars. Trachyte has been used as decorative building stone and was extensively used as dimension stone in the Roman Empire and the Republic of Venice. Ancient Romans attributed the empire's rise to a mysterious extraterrestrial artifact, and now we'll delve into the surprisingly complex chemical composition of this remarkable stone. Trachyte has a silica content of 60 to 65% and an alkali oxide content of over 7%. This gives it less CO2 than rhyolite and more Na2O plus K2O than dacite. These chemical differences are consistent with the position of trachyte in the TAS classification, and they account for the feldspar-rich mineralogy of the rock type. Trachytacite occupies the same field in the TAS diagram as trachyte, but is distinguished from trachyte by a normative quartz content over 20%. Trachytacite is not a recognized rock type in the QAPF classification, where rocks rich in alkali feldspar and with quartz over 20% would be classified as rhyolites. Ancient Romans attributed the empire's rise to a mysterious extraterrestrial rock, and now we'll delve into the fascinating mineralogy behind this incredible story. The mineral assemblage of trachytes consists of essential alkali feldspar. Relatively minor plagioclase and quartz or a feldspathoid such as nepheline may also be present. This is reflected in the position of the trachyte fields in the QAPF diagram. Biotite, clinopyroxene, and olivine are common accessory minerals. The plagioclase is typically sodium-rich oligoclase. The alkali feldspar is typically also sodium-rich sanidine anorthoclase and is often cryptoperthitic with alternating microscopic bands of sodium feldspar albite and potassium feldspar sanidine. Trachytes are typically fine-grained and light-colored but can be black if they consist mostly of glass. They are often porphyritic, with large, well-shaped crystals of sanidine in a ground mass containing much smaller, imperfect sanidine laths. Rhomb porphyry is an example with usually large porphyritic rhomb-shaped phenocrysts embedded in a very fine-grained matrix. Some of the best-known trachytes, such as the trachyte of Drachenfels on the Rhine, show striking porphyritic character, having large sanidine crystals of tabular form an inch or two in length scattered through their fine-grained ground mass. In many trachytes, however, the phenocrysts are few and small and the ground mass comparatively coarse. The ferromagnesian minerals rarely occur in large crystals and are usually not conspicuous in hand-sized specimens of these rocks. Two types of ground mass are generally recognized. The trachytic, composed mainly of long, narrow, subparallel rods of sanidine, and the orthopheric, consisting of small squarish or rectangular prisms of the same mineral. Sometimes granular augite or spongy rebecite occurs in the ground mass, but as a rule this part of the rock is highly feldspathic. Trachytes very often have minute, irregular vesicles which make the broken surfaces of specimens of these rocks rough and irregular, and it is from this distinctive texture that they received their name. It was first given to rocks of this class from Auvergne and was long used in a much wider sense than that defined above, so that it included quartz trachytes, now known as lipperites, and rhyolites and oligoclase trachytes, which are now classified as andesites. Quartz is rare in trachyte, but tritomite, which likewise consists of silica, is not uncommon. It is rarely in crystals large enough to be visible without the aid of the microscope, but in thin sections it may appear as small hexagonal plates which overlap and form dense aggregates, like a mosaic or like the tiles on a roof. They often cover the surfaces of the larger feldspars or line the vesicles of the rock, where they may be mingled with amorphous opal or fibrous chalcedony. In the older trachytes, secondary quartz from the recrystallization of tritomite is not rare. Of the mafic minerals present, augite is the most common. It is usually of pale green color and its small crystals are often very perfect in form. Brown hornblende and biotite occur also, and are usually surrounded by black corrosion borders composed of magnetite and pyroxene. Sometimes the replacement is complete and no hornblende or biotite is left, though the outlines of the cluster of magnetite and augite may clearly indicate from which of these minerals it was derived. Olivine is unusual, though found in some trachytes, for example those of the Arso and Ischia. Basic varieties of plagioclase, such as labradorite, are known also as phenocrysts in some Italian trachytes. Dark brown varieties of augite and rhombic pyroxene, hypersthene, or bronzite have been observed but are not common. Apatite, zircon, and magnetite are practically always present as accessory minerals. Occasionally, minerals of the feldspathoid group, such as nepheline, sodalite, and leucite, are present in trachytes, and rocks of this kind are known as foid-bearing trachytes. The sodium-bearing amphiboles and pyroxenes, so characteristic of the phonolites, may also be found in some trachytes. Thus, aegirine or aegirine augite forms outgrowths on diopside crystals, and rebecite may be present in spongy growths among the feldspars of the groundmass, as in the trachyte of Berkham on the Rhine. Glassy forms of trachyte obsidian occur, as in Iceland, and pumiceous varieties are known in Tenerife and elsewhere, but these rocks, as contrasted with the rhyolites, have a remarkably strong tendency to crystallize, and are rarely to any considerable extent vitreous. Trachyte is the usual silica-rich end member of the alkaline magma series, in which alkaline basaltic magma experiences fractional crystallization while still underground. This process removes calcium, magnesium, and iron from the magma to give it a composition close to that of alkali feldspar. As a result, trachyte is common wherever alkali magma is erupted, including late eruptions of ocean islands and in continental rift valleys and mantle plumes. Only rarely does magmatic differentiation proceed beyond trachyte to phonolite or even more evolved alkaline magmas. Trachyte also occurs in areas of bacarc extension, such as the northern Aegean Sea and the Aeolian Arc of Italy. The Aeolian bacarc includes the Campi Flegrei volcanic field, where trachytes have been erupted. Trachytes are well represented among the Cenozoic volcanic rocks of Europe. In Britain, they occur in sky as lava flows and as dikes or intrusions, but they are much more common on the continent of Europe, as in the Rhine district and the Eifel, also in Auvergne, Bohemia, and the Euganean Hills. In the neighborhood of Rome, Naples, and the island of Ischia, trachytic lavas and tuffs are of common occurrence. Trachytes are also found on the island of Pantelleria. In the United States, trachytes crop out extensively in the Davis Mountains, Chizos Mountains, and Big Bend Ranch State Park in the Big Bend, Texas region, as well as southern Nevada and South Dakota, Black Hills. There is one known voluminous flow from Powwow on the north flank of Hualalai in Hawaii. Here the trachyte is glassy and black in color. In Iceland, the Azores, Tenerife, and Ascension there are recent trachytic lavas, and rocks of this kind occur also in New South Wales, Canberra Range, Queensland Main Range, East Africa, Madagascar, Yemen, and in many other districts. Among the older volcanic rocks, trachytes also are not scarce, though they have often been described under the names orthophyre and orthoclase porphyry, while trachyte was reserved for tertiary and recent rocks of similar composition. In England, there are Permian trachytes in the Exeter district, and Carboniferous trachytes are found in many parts of the Central Valley of Scotland. The latter differ in no essential respect from their modern representatives in Italy and the Rhine Valley, but their augite and biotite are often replaced by chlorite and other secondary products. Permian trachytes occur also in Thuringia and the Saar district in Germany. Alkaline rocks such as trachyte are rare in the Archean, but become common in the Proterozoic. Alkaline rocks with an age close to 570 million years are common around the perimeters of many continental shields and are evidence of worldwide rifting at that time. Closely allied to trachyte is the rock type called keratophyre, which is the sodium-rich plagioclase equivalent of trachyte. Ancient Roman structures defy conventional explanations, leading to a fascinating theory about an extraterrestrial origin.